Okay, lesson 1.6 is transformations of functions. So the simplest form in a set of functions that form a family, namely f of x equals a times f of x equals a times f of x minus h plus k is commonly called the parent function. A change made to at least one of the values a, h, and k is called a transformation. So there are four types of transformations. We have a dilation, a rotation, we have reflection, and then a translation. All right, and so transformations are separated into two groups, and we have what they call rigid transformations and non-rigid transformations. Rigid usually means like it's firm, so therefore a rigid transformation is going to keep the original shape and the size. It's not going to change. Non-rigid transformations are going to have our stretch and our shrink factors. They're going to distort the shape of the graph. They're going to change the shape of it. Okay, so instead of filling out these tables, I'm actually going to bring up just a whiteboard here, and we're going to talk about transformations using it. And so you might want to get a sheet of paper. So we got this general equation, okay? Y equals A times BX minus H plus K. And I put the BX minus H in parentheses because it's going to be together. But it doesn't matter if it's together in parentheses with an exponent on the outside, or if it was absolute value bars instead of parentheses, or if it was a square root symbol instead of parentheses. The BX minus H is always going to be together. All right? A and K will always be on the outside. So let's talk about what these do. So first let's look at A. A is outside the parentheses, so it's vertical. It's being multiplied, so it means it's going to be a stretch or a shrink. Now think about it. If you multiply something by 2, what does it do? It gets bigger. And so if we multiply by a number greater than 1, it's going to cause our graph to get bigger or to stretch. And so if A is greater than 1, it's going to be a stretch. And if A is between 0 and 1, it's going to be a shrink. But what if A is negative? Well, the negative has its own role, okay? So if you have a negative A, that means it's going to be a reflection across the x-axis. And then I'm going to go ahead and jump over to that K since it's outside the parentheses as well. Since it's outside the parentheses, that means it's going to be vertical. It's being added or it could be subtracted, which means it's going to be a shift. And vertical shifts go up or down. So if it's a plus K, it's going to make our graph go up. And if it's a minus K, it's going to make our graph go down. Both of these, the A and the K, will affect my Y value since it's not inside the parentheses with the X. So now let's talk about what is in parentheses with the X, okay? So we got that B. B is inside the parentheses, so it's going to be horizontal. It's being multiplied, so it's going to be a stretch or a shrink. Now, the thing with everything that's in, the catch with everything in parentheses is it doesn't do what it's supposed to do, okay? It's trapped inside and it's rebelling. So therefore, we said just a minute ago that if we multiply by 2, something's going to get bigger. But because this one does the opposite, it's going to make, if B is greater than 1, it's going to be a shrink. And if our B is between 0 and 1, it's going to be a stretch. Of course, if B is negative, that just means it's a reflection across the y-axis. And then we have H. H is inside the parentheses, or it's inside with the X, so it's horizontal. It's being added or subtracted, so it's going to be a shift. Horizontal shifts go left or right. Now we would think if it said a plus 2 that we would go to the right 2. But remember I told you x does the opposite. So if it's a positive h, it's going to go left. And if it's a negative h, it's going to go to the right. And so b and h are both inside with the x. So they are going to affect our x value. So what will this do to our tables? Well, let's start with y, because y is on the outside of the parentheses. Y does what it's supposed to. And so you got to think about PEMDAS. When we're looking at the y values, we see that we have an a times and a plus k. PEMDAS says we multiply first. So we're going to take our y times a, and then we'll add our k value. But x, remember x always does the opposite. And x is going to rebel. It's not going to do PEMDAS like it's supposed to. So we know PEMDAS is a multiply before you add or subtract. X is going to add or subtract first, and then it's going to multiply, but it's still rebelling. It's not going to multiply. It's actually going to divide by that b value. All right, and so that's how it's going to affect those parent tables that we talked about in 1.5. Now, going back to our notes. So we just covered almost everything here except the absolute value, and we'll talk about that when we get to the example with it. So we're going to use the parent functions from our previous lesson to describe how the graphs of each of the following functions will be transformed. State the types of transformations and graph the function. All right, so let's just go through this. We're going to do it piece by piece. So when we look at A, the first thing I notice is we have that negative sign there. So remember, the negative on the outside means it's going to be a reflection across the x-axis. Then inside we have a negative 2. Well, that's my h value, so it's going to be a horizontal shift. It's horizontal because it's inside with x. It's being added or subtracted, so that means it's a shift. Now remember, horizontal shifts do the opposite of what we think. Negative 2, we would think we would go to the left to negative 2, but we're not. We're going to go right to 2. And then we have this plus 4 at the end. It's outside the parentheses, so it's vertical. It's being added or subtracted, so it's a shift. And it's a plus 4, so it's going to go up 4. All right, so what is our parent function here? Well, we can see that we have the x, and we also have the exponent as squared. So our parent function is going to be the y equals x squared. And so in 1.5, we learned about some tables to help us graph. And this is one of those tables. So either you can look back, or you can just work it out. It's negative 2 to 2. Plug it into the equation and find your y values. And it didn't tell me to graph the parent function, but I'm going to go ahead and do that so that we can see what is happening to our transformation graph and make sure that we've got it down correctly. All right, so here is my parent function. Now let's go do that transformation function. So do I have anything that is going to affect my x's? Well, is there anything inside with x? There is. It says x minus 2. But remember, x does the opposite, so we're not really going to subtract 2, we're going to add 2. So I'm going to take all of these x values over here, and I'm going to add 2 to each one of them. So negative 2 plus 2, negative 1 plus 2, 0 plus 2, 1 plus 2, and 2 plus 2. And then my y values, what am I going to do to them? Well, I see that I have a negative 1 times here, and I have a plus 4. And we know PEMDAS says we multiply first, so we're going to multiply by negative 1, and then we're going to add 4. So I'm going to go to my table, and I'm going to take these y values of the parent function and multiply each of my negative 1 and add 4. So my first one is 4 times negative 1 is negative 4 plus 4 is 0. Now notice the last one is also a 4, so that means that it's going to be 0 as well. My next one was a 1, so 1 times negative 1 is negative 1 plus 4 is 3. Notice the next to last one was also a 1, so it's also going to be 3. And then we have 0 times negative 1, which is 0 plus 4 is going to be 4. And so there's our new ordered pairs, and let's plot them. And so once we do that, let's compare. So let's go back and look at what we said it was going to do. We said it was a reflection across the x-axis. Is it? Did it flip upside down? It did. We said it was going to move to the right 2. We'll look at the vertex. The vertex was at 0, 0, and now it's up at 2, 4. So it did go to the right 2. And we said it was going to be a vertical shift up 4. My vertex is up at 4, therefore it did that as well. So there's our transformation for this function. So for B, we're going to do the same thing here. The only difference is I have a different parent function. So those bars mean absolute value. So we know that this is going to be an absolute value function, and that we're going to end up using our parent table in the end. So I'm going to go ahead and write that down. So either I can, if I don't have it memorized, I can work it out. Absolute value of negative 2 is 2. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Now, before we actually, I'm going to go ahead and graph that since we're here right now with it. So there's our parent function. And now let's talk about the transformations that are going on here. So as I go through this, I can see we have a 2 on the outside. It's outside the parentheses, so it's vertical. Or I shouldn't say parentheses, I'll get this one. Outside the absolute value bar, so it's vertical. It's being multiplied, so it's either a stretch or a shrink. Because when you, remember, vertical does what's supposed to. When you multiply by 2, it makes something get bigger, so it's going to be a vertical stretch. And we're just going to say by 2. Technically, it should be by a factor of 2, but I'm trying to make it where you don't write quite as much. Then we have this plus 3. Well, it's inside with x, so it's horizontal. It's being added, therefore it's going to be a shift. And plus 3 is going to go to the left 3, because remember, it does the opposite. Then we have this minus 5. It's outside of the absolute value bar, so it's vertical. It's being subtracted, so it's going to be a shift. And it's negative, so it's going to go down 5. And so let's work on our table now for this one. Is there anything that's going to affect my x's? Well, if there's anything inside with x, it will affect the x. And we see it says x plus 3. So remember, x is an opposite. We're not going to add 3. We're going to subtract it. Now the others are my y. So I see times 2 and minus 5. Y does what it's supposed to. So we're going to multiply first and then subtract. So let's take the x values over here and let's subtract 3 from them. So negative 2 minus 3, negative 1 minus 3, 0 minus 3, 1 minus 3, and 2 minus 3. And then we're going to take our y values, multiply by 2, and subtract 5. So 2 times 2 is 4, minus 5 is negative 1. Now notice the last one was also a 2, so I'm going to go ahead and put that down here as well. It's going to be the same. Then the next one was a 1, times 2 is 2, minus 5 is negative 3. Well, the next to last one was also a 1, so it's going to be negative 3 as well. And then the middle one there was 0 times 2, which is 2. I'm sorry, 0 times 2 is 0, minus 5 is negative 5. And so we can graph this. And so we can see here that we did go Well, it says it's a vertical stretch by 2. Remember, if it stretches, it's going to make it more narrow. It stretches vertically. We're pulling it up and down, and so it's going to make it more narrow, and it is a little bit more narrow. Horizontal shift left 3. Look at that vertex. Is it to the left 3? Yes, it is. And vertical shift down 5. Did the vertex go down 5? It did. So therefore, we've got everything covered there. All right, C. Same idea, but now we're using the absolute value function. So, but before we get going, we have to be careful when there's a negative inside with x. Because in order to read the equation to see what our transformations are doing, we're going to use a different equation than what we're actually going to use to find our table. So first thing I'm going to do here is I'm going to rewrite this, and I'm going to put the x first inside. So we have a negative x plus 2, and then we still have our minus 3 on the outside. Now we're going to use that equation for our table. But to read the transformation, we have to have the negative out in the very front there. So we're going to pull the the negative out. So we're going to factor out that negative, and it's going to leave us with x minus 2 inside, and then we've got our minus 3 at the end. So we're going to use the third equation there to tell about the transformation. We're going to use the second equation to actually work our table. Okay? So this one's for the table. This one's for the words. All right, so let's do the words first. So what is that negative inside going to do? It's going to be a reflection across the y-axis. And what is the minus 2? Well, it's inside with the x, so it's going to be a horizontal. It's being subtracted, so we know that means it's a shift. And minus 2 is going to go to the right 2. And then what does the minus 3 at the end do? Well, it's not with the x, it's vertical. It's being subtracted, so it's a shift. Vertical shifts go up or down, and since it's minus 3, it's going to go down 3. Now our parent table for the square root of x, we haven't done that yet. So I'm just going to do that right here. So the square root of x is parent table. Remember, this is one of the few that we didn't go from negative 2 to positive 2 because you can't take the square root of negative numbers. So we wanted to start at 0, and then we wanted to pick numbers that we could take the square root of, such as 1, 4, and 9. And so the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And so we could go ahead and graph our parent function here. And I don't have enough to do the 9, 3, but that's okay. We've got the idea. And so now that we've got that, we can go ahead and create our table for our new function here. Was there anything that's going to affect the x's? Well, first, let's go ahead and do the y's. Anything that's going to affect the y, the minus 3. So we're going to take y minus 3. And so let's go ahead and do that. So I had 0 for my first y. I'm using these y's right here. 0 minus 3, 1 minus 3, 2 minus 3, and 3 minus 3. Now for my x's, be careful here. I'm actually going to change colors. Let's see. Let's go with this one. All right, remember, we have to use this one for our table. Otherwise, when we do this, if we use the bottom one, we already took that negative out of the 2, and then we're going to end up putting the negative with the 2 again, okay? We're going to take it out again, and we're not allowed to do it twice to that 2. So we have to go back up to this one here. So this one says negative 1 times x plus 2. Remember, with x, we do the opposite. So we know we're actually going to subtract 2, and then we're going to divide by the negative 1. So I'm going to, let's see, I don't have much room here. I'll write small. All right, so we're going to take these x's right here, and we're going to do that to it. So we got 0 minus 2 is negative 2, divided by negative 1 is positive 2. 1 minus 2 is negative 1, over negative 1 is positive 1. 4 minus 2 is 2, over negative 1 is negative 2. And 9 minus 2 is 7, over negative 1 would be negative 7. And so now we can plot those points right there. So we got 2, negative 3, 1, negative 2, 2, negative 1, and negative 7, 0. And so now we can draw in this graph, and we can check. Did it reflect across the y-axis? Yes. Before it was going towards positive infinity, now it's going towards negative infinity. Is it a horizontal shift right 2? Look at that end point. Did it move to the right 2? It did. And is it a vertical shift down 3? Did that end point move down 3? It did. So there's our graph of this function. And let's do one more for this video. Let's do D. So what is our parent function? Well, you see the x and you see the cube. So our parent function is going to be x cubed. And so we can do our table. And we can go ahead and graph that if you want to, so it's done with. Now I can't graph the negative 2, negative 8, but I know it's way on down there. And so be careful on this one because I can't graph the 2, 8 either, so it almost looks linear, but this is cubic. So you know that when you go to 2, you're going to be going way up here to get to that 8. And when you do the negative 2, you're going to be going way down there to get to that negative 8. And so there's our cubic parent function. So let's go through these pieces here. What does each part do? So what is the negative? Well, the negative is going to be that reflection across the x-axis. What about the 1/2? Well, it's outside, not with the x, it's vertical, it's being multiplied, so it's a stretch or compression, or shrink, stretch or shrink. So what happens when you multiply something by 1/2? It gets smaller. So we think this graph is going to get smaller, and y does what it's supposed to, so it does. So it's going to be a vertical shrink by 1/2. Now think about this. If I vertically, from the top and bottom, squish something down and shrink it, it's going to get wider. It's going to go out the sides there. So I expect my graph to get wider because of that. Then we got this minus 3. So it's inside with the x, so it's going to be horizontal. It's added or subtracted there, so it's going to be a shift. And a minus 3 is going to go to the right 3. And then we get that plus 2. It's not with the x, so it's vertical. It's being added, so it's a shift. And a plus 2 is going to go up 2. And so now we're ready to do our table. What's going to affect my x? Well, I have x minus 3, so we know we're going to do the opposite, so we're going to add 3. And let's go ahead and do that. So we're going to take these x values, and we're just going to add 3. So negative 2 plus 3, negative 1 plus 3, 0 plus 3, 1 plus 3, 2 plus 3. And then my y's. My y's are a little harder this time. We have this negative 1/2 times, and we have this plus 2. So we're going to take y times that negative 1/2, and then we're going to add 2. So let's take these y values, and let's do that. So we got negative 8 times negative 1/2, which is 4, plus 2, which is 6. Then I have negative 2, it's a negative 1. Negative 1 times negative 1/2, which is 1/2, plus 2, which is 2.5. Then we have 0 times negative 1/2 is 0, plus 2 is 2. Then we have 1 times negative 1/2 is negative 1/2, plus 2 is 1.5. And then we got 8 times negative 1/2, which is negative 4, plus 2 is negative 2. All right, so make sure you got that down. I'm about to erase my work so that I can draw in my graph. Actually, I think I can draw it in without erasing it. All right, so we got the point 1, 6. 2, 2.5, 3, 2, 4, 1.5, and 5, negative 2. All right there, so look what happened. Let's check. Did it reflect across the x-axis? It flipped upside down, yes. Vertically it shrank by 1/2. Did it get wider? Look at the points in the middle there. Notice how they seem to look wider? It did. Did it go to the right 3? Look at that middle point. Did that middle point go to the right 3? It did. And did it go up 2? Yes, it did. And so there's our graph there.